Next topic in manufacturing is machining and machine tool operations, which is also called as metal cutting. It is the highest weightage out of all topics in manufacturing. You will get 5 to 7 marks. Metal cutting or machining and machine tool operations, 5 to 7 marks, highest weightage in manufacturing. Easy chapter where you can score lot of marks. Metal cutting. So here metal cutting is why we do is especially metal removal process. Material removal process are the it's like different methods are there. So we discuss each and every method and conventional method, non-conventional methods, abrasive process, all the process and mechanism in each process. First of all, material removal process. There are three broad classifications of material removal. So these three are like, one is conventional machining, conventional machining is where the tool is directly in contact with the workpiece, and you can say that this is one of the turning and drilling, milling, other machining operations, broaching, sawing, everywhere, where there is tool and as well as the workpiece in direct contact with each other. The mechanism is material removal, and in all these process the tool is hard. In conventional machining process, tool harder than workpiece. Example: turning, drilling, milling, broaching, etc. Next further is abrasive process. The mechanism here is abrasion. Here abrasion is especially multi-point cutting operation, and where each point acts as a cutting tool. So all multiple tools will come in contact with the workpiece to remove the minute part of the material. So that's why it is called grinding is abrasive process, abrasion. So rubbing. So example: grinding and honing, lapping. Third type of material removal is non-traditional machining. Non-traditional machining. Non-traditional machining. It's also called unconventional machining. Non-traditional machining process. Unconventional machining process where the tool workpiece is harder than tool. So non-traditional machining is it's special process where if you want to produce micro holes and if you want to cut very high hard materials. This is examples: electrochemical machining, electron beam machining, electric discharge machining, EBM, EDM, electron beam machining, ultrasonic machining. We will discuss in detail all this machining process. This is just introduction of the material removal process. Next, cutting tools. What is cutting tool? Cutting tool is a tool which is used to remove the material. Which is used to remove metal or material from workpiece. Workpiece may be either metal or different material. Okay. So what are the types of cutting tools? One is single point cutting tool. So what is this single point cutting tool? In single point cutting tool, why do we call it single point cutting tool? If you look at the shaper, lathe, all these are single point cutting tool. Only single cutting edge will be present. Single cutting edge is present in single point cutting tool. So example is lathe machine or lathe tool, whatever the tool you use in lathe, shaper, here the tool is fed axially at a uniform feed per revolution. Tool feed is axial to the workpiece. So that's about single point cutting tool. Mostly we use for commercial purpose, material removal, and if you want to remove the diameter, reduce the diameter, we use single point cutting tool. Suppose in lathe turning for example, generally we use where single point cutting tool is used to remove reduce the diameter of the workpiece. Multi-point cutting tool. So in the same way, multiple cutting edges are, if multiple cutting edges are present, then it is called multi-point cutting tool. Multiple cutting edges are used to remove material from workpiece. Example, drill bit, which is used in drilling machine. Another one is drilling is one, milling is one, broaching is one, milling cutter, grinding wheel, So grinding is also a multi-point cutting tool, grinding wheel, where each point acts as a cutting tool. So grinding, actually finishing operation, but the tool, the grinding wheel, it has multi, millions, I mean thousands of points, cutting edges. So each cutting edge acts as a one tool. Milling is for dividing the periphery into equal divisions. So the milling is milling cutter is also a multi-point cutting tool. So in multi-point cutting tool, advantage of multi-point cutting tool is because there are multiple cutting edges which comes into action, more material removal rate is high. Material removal rate is high in multi-point cutting tool. Nomenclature of cutting tool. So for nomenclature of cutting tool, there are two different methods for nomenclature. One is American Standard Association, another one is orthogonal rectangle system. First one is American ASA system. American Standard Association. ASA system angles are measured with respect to coordinate axis. That means perpendicular axis, three perpendicular axes. Simple diagram, single point cutting tool. So from this we discuss only single point cutting tool. So here is single point cutting tool, small diagram which explains each and angle. Here if you look at this, face is the top surface of the tool, and flank is side surface, side and front. That's why it is called side flank and end flank. So this is simple diagram of single point cutting tool. End flank. Side flank. I will give the designation with some alphabet numbers. We can explain it later. This one is alpha B, which is more important, called back rake angle. Alpha B is called back rake angle. What is the purpose of back rake angle? So back rake angle, it may be actually, it guides the direction of chip flow. Back rake angle guides the direction of chip flow. First of all, I will just write the names and then we can discuss in detail. Alpha S is side rake angle. Theta is end relief angle. Theta S side relief angle. CE end cutting edge angle. CS side cutting edge angle. In side view, I will suppose if you look at the tool in from side view instead of front view, the diagram will be bit easy to understand, but we can show only few angles. So in side view, it is a diagram for single point cutting tool. This one is alpha B, back rake angle. So that is the most important angle, and this one is end relief angle. These two angles can be shown in front view. And in top view, it is called side relief angle, side relief angle, and as well as side end cutting edge angle. Side rake angle, CS side cutting edge angle. This one is end cutting edge angle, another one. End cutting edge angle. So you have to imagine how it looks like. Just a rectangular block with slight inclinations. So ASA system is notation is alpha B, so back rake angle, alpha S, theta E, theta S cutting edge angle, side cutting edge angle, and another one is R. R is nothing but nose radius. Radius of the the end point of the tool, nose radius. So how this each parameter will affect in the machining process, that is more important. Back rake angle, it is an angle between the face of the tool and a line parallel to the base of the tool and measured in a plane perpendicular to the side cutting edge angle. Back rake angle, first one. Back rake angle is an angle between the face of the tool and a line parallel to angle between the face of the tool and a line parallel to the base of the tool. And measured in a plane perpendicular to the side cutting edge angle. So if you look at the diagram, angle between the face is the top surface of the tool, face of the tool, and a line parallel to the base of the tool and measured in a plane perpendicular to the side cutting edge angle. So next, here what is the purpose is, it guides the direction of chip flow. Back rake angle is the guides the direction of chip flow. And how back rake angle can be either, to control that purpose, to guide the direction of chip flow. And to give protection to the tool point. It also helps us to give protection to the tool point. And it also controls the directions of the resultant force on the tool and the chip flows. It influences the cutting forces and as well as power and surface finish. Based on the value of the angle, your surface finish will vary. And effect of performance, the angle can be either positive or negative or zero. You have to use positive for a particular application, like for hard materials. You have to use for brittle materials, especially hard and brittle materials. You have to use negative back rake angle. And if it is positive, so alpha B back rake angle is either positive or negative or zero also. So negative alpha B equal to 0 is used, that means zero back rake angle is used for high strength alloys like brass, bronze, for machining high strength alloys like brass and bronze. So alpha B 0 means just it is a rectangle, there is nothing inclination. That's about a back rake angle. So I will just show you how it looks. Back rake angle 0 means side view I am showing. So here there is no zero angle, it is flat. Okay, that's why it is called zero back rake angle. Alpha B is negative, is used for brittle materials. Negative means used to machine brittle materials Why brittle materials? Because they are hard and brittle. So if you use positive rectangle which include which results high force, there may be failure takes place. The negative back rectangle will be in side view, it looks like this. So negative back rectangle. If you consider this as a base, whatever angle is this one is alpha b, negative alpha b, because it is above the horizontal line. Alpha b is positive when positive used for normal cutting operation. So positive alpha b looks like initial diagram. This is positive alpha b. Here the strength of the tool with large rake angle is weak, because if you increase the back rake angle goes on, the strength will decrease and the tool point may break off readily, and on the contrary tool with negative rake angle are stronger. Okay. So strength of the tool decreases as we goes on increasing the angle of the tool. Heat conduction. Tool with large rake angle do not conduct heat readily, whereas tool with negative rake angles have better heat conductivity, because the surface area of contact is more, so heat transfer will be more. So negative rake angle has higher heat transfer compared to the positive rake angle. Cutting force. Cutting force, with decrease in the rake angle, the shear plane angle decreases, and for the same depth of cut, and the extent of the shear plane increase, and thereby the cutting force increases. So the cutting force increases as we increase the with a decrease in the rake angle. Power consumption. With large rake angles, the cutting forces are less, thereby power required to make the cut is also reduced. Back rake angle controls the point of initial contact between the tool and the workpiece, so thereby it exercises control over the strength of the tool point. Here we need to discuss only difference between positive back rake angle and negative back rake angle. Those are more important. We will list out the few differences. Alpha b positive, alpha b negative. So positive back rake angle, first one, less rough surface. So surface finish is good, more rough surface will be produced. Less curling of chips. More curling of chips, metal chips. Here